Alright everybody, in this video we're going to officially learn how to graph inequalities in the second dimension, so essentially linear inequalities. So just to give you a backtrack of what y'all did last year, if you had an inequality that looks something like x is greater than 2, on the graph, right on the number line, this is 2. Let me use a different color for this. Since it's not equals 2, it would be an open circle, and we're talking about numbers bigger than 2, so it would be numbers on this side. Similarly, if you had something that looked like x is less than or equal to than -3, here's the number line, here's -3. So we're talking about numbers that are smaller or equal to than -3. So obviously we would include -3 because it's equals, right? Then it's all the numbers smaller than -3. We're going to apply the same rules, except now we're going to be graphing in 2 dimensions. So you can title this Graphing a Linear Inequality. And I would personally recommend you do this on graph paper. And if you don't have any, you can actually find some on the internet and go print it out. But if you don't have any of that, that's fine. You can just sketch it, okay? So we're going to be graphing the inequality y is greater than or equal to 3x minus 2. So remember, when graphing a linear inequality, actually, no, you don't remember because you've never done this. So I'm going to tell you this straight up. When you're graphing linear inequalities, graph the linear equation first. Just graph it, okay? So it should look something like, graph the equation y equals 3x minus 2, which at this point everybody should know how to do. So the y-intercept is -2, which means it's going to cross down here at -2. The slope is 3/1. So that means we're going to go up by 3, 1 to the right, up by 3, 1 to the right, up by 3, 1 to the right, up by 3, 1 to the right. And you just keep doing this until you get enough points. And you can even go the opposite way. Down 3, 1 to the left. Down 3, 1 to the left. So now you got this little nice set of points right here. This is where you decide, is my line going to be bold or is it going to be dotted? This is the same idea as including the points or not including the points. And what you need to check is this right here. Does that have an equal sign? You got to ask yourself, does it have an equal sign? Yes or no? If it does, you're going to include the points, meaning you're going to draw the bolded line. If you don't have the equal sign, it's going to be dashed. Right? Something like that. If it's greater than or equal to or less than or equal to, it's going to be a bolded line. And if it's just greater than or less than, it's going to be dotted. Since this equation has the greater than or equals to, we're going to include the points, meaning you're just going to do this. You're going to draw the line. Draw the arrows. And we're almost done here. We're almost done. Now, this is an inequality, which means we're finding solutions to this inequality. The solutions lie either in region 1 or region 2. What I mean is, this linear equation that we just graphed, you can think of it as a border, right? It's the border between, country 1 and country 2. On one of these sides, all of the solutions exist. And on the other side, none of them are solutions. What this means is, if you can test a point, doesn't matter in which region it is. If you test one point, it should tell you whether it's a solution or if it's not a solution. It tells you basically where the solutions exist. And the point I always recommend, if possible, is that point, the origin. It's so easy to plug in 0, 0 as your x and your y. So we're going to check if x equals 0, y equals 0 is a solution. Okay? So we're going to grab our inequality. Let me zoom in on this side so we have something to write with, or something to write on. Y is greater than or equal to than 3x minus 2. And all you're going to do is plug in 0, 0. And then you do the math. 3 times 0 is 0, minus 2, negative 2. So you're left at this inequality. Now let me ask you, is 0 bigger than or equal to negative 2? If you said yes, you're absolutely correct. 0 is bigger than negative 2 because on the number line, 0 is farther to the right than negative 2. Negative 2 is to the left. This is a true statement. What this means is the point 0, 0 is a solution, which means the region 1 has all the solutions. Region 1 has all the solutions. So all of this is your solution set, right? All of these points, if you were to plug them in into the inequality, would give you true statements. All of these points over here on region 2 would not give you solutions. It would give you a false statement. And let's just check. It doesn't take more than 10 seconds. 1, 2, 3. Let's just try this point out. 3, 0. So we write down the inequality. Y is greater than or equal to 3x minus 2. You plug in x equals 3, y equals 0. You do the math. Is it true that 0 is bigger than 7? No. This is a false statement. And what this tells you is this point 3, 0 is not a solution to the inequality. Meaning, region 2, or this country 2, whatever you want to call it, does not get shaded. Let's try another one. Hey, okay, here we go. Let's try another one. Y is greater than or equal to than 2x. So first things first, you graph this like a normal equation, okay? Actually, let me erase that. So you're gonna graph this like a normal equation, y equals 2x. You don't have a y-intercept, so you know it's gonna cross through the origin. So the slope is 2 over 1. So you go up by 2, 1 over, up by 2, 1 over, up by 2, 1 over. Once you have enough points, you kind of have a sense of what the graph is going to look like. Ask yourselves, looking at this symbol here, does that mean we include or not include the points on the line? If you said not include, you're correct, because it doesn't have an equal sign, so you can't include the points on the border. So this is going to look like this. You're going to graph the line like this. It's going to be dotted, or as some people like to say, dashed, whatever you want to call it. So now you have to ask yourself, well, am I going to shade region 1 or region 2? Which side of the border am I going to shade? So you have to ask yourself, okay, I need to test a point. But this is where we run into issues if we were to use the origin. Let me go back to the other. Here, I could use the origin. Let me highlight it in green. Because it's not on the border. Here, the origin is on the border. So we can't use the origin. But you can use one of the infinite points that is not on the line. Doesn't matter which point, honestly, as long as it's not on the line. You can use this point, that point, that point, that point, that point, that point, doesn't matter. Okay? Now I gotta erase all this. So, in my personal opinion, just pick a point you're comfortable with. Something you're comfortable with, okay? Whether it's 3, 0, 0, 3. I personally recommend something with 0 in it. But if you're kind of confused as to how to do 3, 0, right? Which one's the X and which one's the Y, I would just pick something like 1, 1. Now, 1, 1 is in region 2, right? It's barely to the right of region 2, but that's fine. So we're going to try 1, 1. X equals 1, Y equals 1. So we're going to write the inequality. Y is less than 2x. You're going to plug in the numbers. And you get 1 is less than 2. Is that true or false? That's a true statement. What this means is that's a solution. And in fact, all of these points are solutions. All of these points. And that's how you graph linear inequalities. You graph the line, decide whether it's going to be bolded or not bolded or dashed. And then you pick a point to decide or determine which side of the inequality you graph. Now, I can say this. If the equation is greater than, it's going to be the top portion of the line, right? The upper portion, as you see here. You're going to graph, You're going to graph the top portion. And if it's less than, you're going to graph the bottom portion. I personally don't like doing it like that. I like testing points, because then if you have to graph, for example, here's your graph, and your equation comes out to like this. Which way is up and which way is down? You know, it's really difficult to determine that.